rangefinder 500 feet from the liftoff point. At the moment, that's key thing right there, at the moment, the rangefinder's elevation angle is pi/4. The angle is increasing at a rate of 0.14. Woo! Increasing rate 0.14 radians per minute. How fast is the balloon rising at that moment? I want you to read to yourself real quick again.
Remember the first word fell.
Oh. You'll be okay. Okay. So what's going on here? We've got a level field. Whoa, what's going on with my board here? Yeah, what is it doing? What are you doing, board?
It's taking the day off today.
Apparently, it was doing this in pre-calc the other day.
I'm tired. The pen said I'm tired of you pushing me around.
Really?
Are we recording?
Yes, we are.
Yes.
I don't know why.
Whoever made this.
What are you doing?
It's kind of like a hand trap though. It's a trap. If you go into like when the fish shoots really well.
Alright, let's see if this will work now. It is not. Awesome.
The little victories, guys.
See why? It's only reading right here. This is not going to work here.
Yeah, we can't do that.
Oh, it just means Corey might have to move. Because I might be blocking his view. Okay. So we've got a level field tracked by rangefinder. So what we're doing here, let's put my little rangefinder right here. 500 feet from the liftoff point. Let's say this is the liftoff point. Is that 500 constant?
Yes.
Yes, so let's go ahead and write it in there. That rangefinder is not moving. It's the balloon that's moving, correct? So we have a hot air balloon, which I'm thinking, I had a contact teacher, after the AP test, he makes hot air balloons. They have a contest over who can fly most.
Like you have to go up in the air and fly a hot air balloon?
Like, no, you don't get to ride in them. They're hand
Oh, I
hot
thought they
air
were like.
balloons. But they have a contest to see whose hot air balloon can go highest.
This is
Yeah, okay.
I was going to ask about the Kafka's music.
Oh, yeah, it's going on like next week. So I said no because you wouldn't understand all of it. I don't know why they're doing that because all schools would be like, no. So
We get like.
they don't think that through. They're art people. They don't.
Would we get most of it?
You get half of it, so it's not.
Good enough.
I don't know.
So
Okay, here we go. So we have a hot air balloon rising at the moment the rangefinder's elevation is pi/4. So here's what I have a lot of people mistakenly do. First of all, what shape am I looking at here? Triangle. I have a lot of people mistakenly label this pi/4. Why is that a big mistake? It's not constant. Okay. In fact, whoops, raise my balloon. In fact, as that balloon rises, of course, that angle is going to get bigger, correct? It's lower. So this is a variable. Now, what also is rising is the height, correct? That is changing. Now it says at the moment, so it's at one moment, not constant. So theta equals pi/4, but I can't plug that in until after I drive. Okay? So the angle is increasing, so what is that giving me right there? Rate of what? Angle. D theta dt is 0.14 rads per minute.
What's that?
Radians per minute. Right? How fast is the balloon rising? So what are they asking me to find?
Rate of height.
So say dh dt. Ask me to find that. So I've done steps 1 and 2 where I've drawn a picture, labeled what I'm asked to find and what I know. And that is sometimes, guys, the hardest part. Is labeling what you know and what you're trying to find. Now, next thing I need to do is find some sort of equation to relate these?
Tangent one.
Tangent. Don't go to the Pythagorean theorem because that doesn't use theta, correct? We have to use both variables, and tangent will use both of those. So my equation is tangent theta equals h over 500. That is an equation that relates both variables. Now that I have an equation, what do? I differentiate. So, derivative of this is
Secant squared.
secant squared theta
Theta, or d theta.
d theta dt. Over here, what's my derivative? Guys, you're killing me.
500 dHdt.
About 1 over 500 dHdt. Right? Isn't that just a constant? Yes. 1 over 500 dHdt. So now let's plug in. I differentiate, so I'm legal to plug that in. So I want secant squared of pi over 4. The theta dt is 0.14. I'm trying to find dHdt. Okay, now here's the problem. We have to remember our pre-calc for that. That is 1 over cosine pi over 4 squared. Correct?
Yeah.
Okay, what's cosine of pi over 4? Square root of 2 over 2. So when I square root of 2 over 2, I get 2 over 4, which is 1/2, and 1 divided by 1/2 is 2. I have 2. And I know, of course, you could do it by hand, but let's go ahead and multiply and then times it by 500. Give me dHdt. So 2 times 0.14, of course we can get that, 0.28 times 500. Or divide it by 1 over 500, which is the same thing.
140.
What do we get?
I got 140.
140, anyone else? Another 140? Couple 140s? Okay, now we have to decide units. We're talking about height. So what are my units here?
Feet per minute.
Is feet, because we're talking about 500 feet per minute. And it is a rate. Feet per minute. Here we go. That is a pretty fast moving air balloon.
That's really
For hot air balloons, that's actually pretty quick, yeah. Yes? Question?
Would you like to hold there?